Okay, so in this lecture we are going to make the solution for the assignment on Udemy about using design patterns and generic classes to improve the development of the image application. Okay, we will use the same classes that we have developed in the previous assignment as a starting point. So you can collect from the resources this one, assignment generic and design patterns. You can download it and then open it with NetBeans using Open Project, and then open the NetBeans project. So you will have packages. You will have the core packages. These represent the class implementations, and these ones they represent the interfaces. So the first question is about the image factory. You need to create an interface called image factory that contains one method, getImage. And here getImage is not like, for example, get and set methods that we find. It just, the factory has a method that starts with get. It's not the get for the private attributes that we use for encapsulation, but it just uses in get. It can be, for example, anything else, okay? Generate image, create image, anything, but it's commonly used to use the get word in the beginning of the method. And then it has 4 parameters: image type, width, height, and name. The method should return an image object. So I'm going to do that. We have the image is also an interface, which is comparable. I'm going to add another interface here, which is called image factory. So image factory, now this is an interface. It only contains an abstract method. But the real class, or the class implementation, will be responsible for creating image objects. Okay, this is the objective of the factory, is to create image objects. So here we have public, abstract. It returns what? It returns an image interface type, okay, and then get image, and takes 4 parameters. What are these 4 parameters? Image type. Okay, so usually we have the type of the object to create as the first parameter. Then we have int width, int height, and string name. Okay, so now this is the interface. And then the second question, then write the class implementation of this interface called image factory IMPL, which implements the interface image factory. Okay, so let me create the class and then we come back. Now we go to the core project. We create a class which we call image factory IMPL, and IMPL is shortcut for implementation. And of course here the first thing we need to do is what? Implement the interface. Okay, implements image factory. We have to import, and then we have to override, implement the existing or the abstract methods. Of course, now we have to see the details of how we will implement this one. We have 2 types of images. We have gray image and we have RGB image. Okay, so we're going to create any of these 2 types. So the image type can be gray or can be RGB. The method should return an image which is gray image or RGB image. Okay, so here if image type dot equal ignore case gray, else if RGB. Of course, here we're going to create a gray image, and here we will create an RGB image. So I can do image equal. So let me put the image here first, equal null in the beginning, and then image equal new. I have to see the constructor of gray image. Okay, width, height, and string. So I'm going to create this one. Other, okay, and here I'm going to do the same for RGB. I think it's the same thing. And finally, return image. And of course here, because of polymorphism, it's possible to return an image because gray image is an image and RGB image is an image. Okay, they extend image IMPL, and image IMPL already implements image. So the relationship is clear. Now,
what if you return null afterward? Will it be fine?
It's going to return null if it is not gray. If it is not RGB, it's going to return null. Okay. So the object image is going only to change if it goes inside the if statement here or in the if statement here. Otherwise, it's going to be null. Okay. Another thing, it says that the class image factory IMPL should follow the singleton design pattern. Now the same factory class is also a singleton. Same thing, I'm going to apply, okay, I'm going to create a constructor that is private. 3 steps that we do usually. This is my constructor. I create private static image factory IMPL, or it can even be image factory IMPL. Okay, let it image factory, and then instance equal a new image factory IMPL, and then public static image factory get instance return instance. Okay, always we follow the 3 rules. We create a private constructor. Yes, we don't have any parameter here. What's the problem? Should it be non-empty? No. Usually it's empty. In the singleton, usually we construct something that is empty and then we put the values.
Okay. But why you create image factory?
Mm-hmm.
Why you didn't put image factory IMPL equal new image factory IMPL?
Here?
Yes.
This is the instance.
Yes, I know. But the object, the name of the object.
What do you want it to be? What it should be?
There's image factory IMPL.
Here?
Yes.
You want like this?
So it will be different from previous one or the same?
This is the interface and this is the class implementation. We create an instance variable, we create a private constructor, and you create the get instance method.
So if you do it the other way, it will still work, right?
Which other way?
Like if you declare of type image factory IMPL.
Like this? Yes, it will work. It will work. But usually when we have to use polymorphism, we use polymorphism. We always declare, always the rule, declare general, create specific. That's the rule. Okay? I'm just following the same rules that we used to do before. Of course, every time we can do it in many ways, but we try to do it in the best way. Okay? So now we are done with the factory. Now we will create the class image processor. You need to create a generic interface. Now we're going to use generic classes here, or interfaces. Image processor with the generic type I. And the generic type I must extend the image. Okay, so let me do that. It's an interface, so it's called image processor, and will be here. I will do image processor. So if we want to make it generic, we can define the type I here. And this type I will extend image. Okay, so it will be only applied to images. Okay, and this is now an enforcement that we apply on the image processor. And it makes sense. It makes sense because we're going only to process images. The generic interface image processor has two methods. The first method, I am write, and the second method, pixels. Okay, let me put these two methods here. The first method is I am write. So it is public, abstract, void. No, has two parameters. What does it return? I am write. And does it return anything? Void. And an image object of type I. Look now, I, we know that it is an image, and a file name, string, file name. The second method is called number of white pixels. So it's going to return what? An int, because it's a number, which takes as a parameter an image, generic image I. That's it. Okay? So far there is no particular difficulty. Now, you need to create the generic class image processor IMPL, which implements the generic interface image processor. The class image processor IMPL has the same generic type I of the generic interface image processor. We need to override the two methods. Okay, so now let's do it. Class is called image processor IMPL. It must be of generic type I. So I extends image, and the interface here and then implements of I. Okay, so here you should not be confused. Extend image must be here, not here, because here we are implementing. Okay, so now if you don't make extend image, you're going to have, even this one is not going to be accepted, because you have to specify that the type I is, okay, an instance of image. And then here we have to override the methods. Now,
why did we specify the type of the interface for I?
here,
No, the second one.
here,
Yes.
Because if you don't do that, look now, it's going to be for objects or for image. Now here, you have to specify. In any case, it's going to be for image. But since you have specified a generic type T here, okay, it must be also mentioned here. Because now, if you don't do that, and you will do that, so in this case, you can even remove this one. You don't have any generic type I inside the methods. So it's not generic at the end. You define a generic and you don't use it. Okay. So what we should do here, let's see what's requested.
Write to a file.
We write to a file. The method IMWrite should have an image, should save an image to a file. If the image is gray image, then the method IMWrite should save an image to a file in the same format as the previous quizzes of the major exams. You can reuse the same method IMWrite of previous exams and make necessary changes to it. Remind that the structure of the file is illustrated as follows. Same thing. Okay, now let's do that. Here we will make if image instance of gray image. So we will have two cases. صح ولا لا؟ If if image is instance of, else first of all specify what are your two types that you will consider. I think we did before the IMWrite. I don't want to write it again. No. We don't have here. Save. Try to find that. Maybe this one. No, this is IoT. No, this is not employees. This is image class.
You said the way that you want to write.
Professor, they can take it from the example on Udemy.
Yes. Let's put it the easiest way. If we go to polymorphism here, I think we did this one. I think it was in the first assignment, if I'm not wrong.
So we did it, but there was no
No, it was in the first assignment, I remember. In classes and objects, yes, here. The image class. Yes, so I'm going to take this method. Is it going to take everything?
This is read. Because I think it writes load.
Yeah, this is right.
But in this case, There is no Boolean.
No problem. Okay, we will make the changes. Instead of image. Okay, so we try. We need to import file writer. So let's max color be 255. Okay, let's make the changes. String.format, we have the width and the height. How to get the width here? Image dot get width, and here image dot get height. Okay, what else? So same thing here, and same thing here, and this one is image. Don't have okay. Yes, that's all. I am right, so we should return true. We don't have return here, and you don't have return here. Delete. Okay, so this is for the gray image. We just need to import the other one, and then for the let me go back. If the image is RGB image, then the method IamWrite should save an image to a file according to the following format. The first line contains color, image text. The third line contains the width, and then each line contains the three colors in the order red, green, and blue. Okay, so we can do that. I'm going to take all of this and put it here inside the RGB. So until here we keep the same thing. So what we will write here, we have three colors. Dot image.get image. Here we have to cast now. So this is now an RGB image. Okay, so let's convert the image into RGB image. And then we use RGB how to get the color now? It's pixels. Yeah, we have to convert the pixel itself. Do we have, so the pixel, you have gray pixel, RGB pixel, this one. We need to get the red, we need to get three values. Int red, int blue and int green. So how to find the value now from the image?
Get image.
This will be what? Dot get image IG. So this one will return the whole image. IG. This is pixel. Yeah, this is pixel. And you have to cast this one to color pixel. Or RGB pixel IMPL. RGB pixel IMPL. Okay, and then this will be IM dot, or this is pixel, sorry, pixel. This will be now pixel dot get color dot. Yeah, we have to convert this. Or even the color. We have to convert the color. So, okay, let's make it another step. RGB, one moment. We have RGB color. RGB color. RGB is equal to pixel dot get color, and here we have also to cast RGB. You have to cast. This is the interface. You have to cast to RGB color IMPL. And then now we have RGB dot get red. Okay, because you have composition, one box inside one box inside one box. Okay, and then you have to use RGB dot. Is there anyone who find this?
I had difficulties in this part.
Yeah, RGB dot get green. Is it clear?
Yeah, but also, Professor, there is one more thing. When we write fw.write, we write color image instead of p2 and convert it from NA.
Okay. And then you have to write these three different values. Red plus, what is the output here? Space. Okay. Plus green plus space plus blue. And that's it. Maybe this is a little bit tricky, but this is the way how we can solve it. I think I did the same thing in the instructor example. Let me just check. Yes, we need to get the red, RGB color. Okay, so we need to convert this one. Yes, it's the way. This is the way how we must do it. And then the second method, the method number of, this is the last question, right?
No, there was also test class.
Okay. The method number of white pixels must find and return how many white pixels exist in an image. If the image is gray image, the white pixel is characterized by the value 255. So we're going to look for all the values that are equal to 255. We're going to make a counter. If the image is RGB image, the white pixel is characterized by red 255, green 255, and blue 255. write the class implementation of image processor. So here we will do the same thing. If image instance of gray image, else if image instance of RGB image. So here we look for all the values of value 255. Okay, so for every pixel in image dot so we can make a counter int count equals 0. If p dot get color dot you have to cast. So if we cast to gray color here, gray color, dot what's wrong here first? If pixel
Gray image.
no, why here is not showing? This is for each statement.
So we have the pixel as an array, yes.
Yes.
So we cannot convert to just.
Okay, for int I equals 0, I smaller than image dot get image dot length I plus plus. Okay, and then we need to get the color. Int color equal I. We have to make 2 for loops, yes. For in G equal, so this is image dot I at get length, and here we have to make G plus plus.
We don't care about the height and width.
Okay, so here this is the width, yeah. This is the height and the width. Color dot we have to cast to gray color, and we have to import this one here dot get color. Okay, so if color equal to 255, in this case what we will do, count plus plus. واضح? Okay, so we're going to increase the counter by what?
Russ, can you briefly just explain this again?
What to explain? So here, for every pixel, we determine the color. So what is the color? It's the pixel dot get color. Okay, this is going to return a color object, and then we have to cast it to gray color because we are in gray, and the gray color has a value that is byte. That's all. And you have to do the same thing for RGB image. Okay, so we will do the same for loop. The only change will be in the cast of the value here, RGB. So here we will not have, so what we will have, this is red, this will be dot get red, and this is blue, green will be get green, and this is blue, okay, and then if red equal to 55 and green equal to 55 and blue equal to 55, we increase the count. Finally, we make return count. Okay, this is the way how to solve it. So the last question is about the test class image test. What is missing here?
We will use uniform.
Complete the missing code. I did not specify. Okay, so maybe it should be finished in this part. They have something here. The last question is, there is. Maybe we have to use the image factory. Okay, I have to update this part. Okay, that's fine. So now we have completed everything about design patterns and also generic classes. Inshallah, by tomorrow we will start a new chapter.